So last time we stopped methods, operators, methods. Okay, yeah. So we stopped last time discussing this thing to motivate why you may need abstraction data types, right? We said there are multiple ways to insert into a list, right? I told you before, so even in this quiz 10, you had to insert or enroll a student into a course, right? Or add number of courses to a student object, right, at the list. So that means you are inserting into an array or inserting into a list. We said you can do this using multiple ways. You insert at the beginning, you insert at the end, you insert at the middle. This depends on the way you insert. This is how you implement things, right? But how you implement things has nothing to do with that all of these implementations are, at the end of the day, just insertion into a list, right? So if you split the abstraction from the implementation, you tell the user you have the ability, something like a method that is called insert to a list, and then the way you implement it should be hidden from the user. So ADT, or abstraction data types, allows us to separate the abstraction concept from the actual implementation of this concept. We call the implementations data structures. So we said a list is an abstract data type. Data structure, or the implementation, can be an array, can be a linked list similar to what you do in the lab, can be other things, right? Also, queue is an abstraction data type, and then you can use an array to implement a queue. You can use a linked list to implement a queue. You can use other data structures to implement queues. Good? Okay, so another reason why you shouldn't overload the user or like your customer by these kind of implementations, because of the overload of the details of this implementation. I shouldn't worry. And if I ask you, for example, what is the difference between these two operators, you may not even remember, right? Like, can someone say what is the difference between these two? Yeah? What is even this? The shift, right? Shift right. But we have differences between both. One of them is arithmetic shift, where you pad the last bit, the sign, right? And this is especially for sign numbers. The other one is just the normal shift, which is you pad by zeros, right? So if I ask you about this, maybe you don't even remember. And this is two different ways of implementing a shift. Compare this with you are telling a user that you are inserting at the beginning, at the end, in the middle, and the way you implement the insertion at the middle is, I don't know, you define a pointer at a certain point, and then you assign your node to this pointer, and then you shift the pointer by one. These implementation details are very heavy, and also they are very easy to confuse customers, right? That's why you should separate them, you should hide them from your customer or programmer that is using your class. Good? So as I said, a list is just an abstraction data type which holds a sequence of values, and they can be implemented using multiple things, arrays, linked lists, and then the way you insert can be at the beginning or at the end, it doesn't matter. So one important thing here as well is different data structures have different advantages over other data structures. Let's compare, because given that you get introduced to linked lists in the lab, or at least some of you, compare this with an array, which all of us know, right? What is the advantage of an array? What is the advantage of an array? Yeah? Yeah, so you can access any element given a constant time, which you will see in 2SI, this is called O1. O1 means it's a fixed time access. If you access the first element or the last element or any element in between, it doesn't matter. You just use this index I of the array, and it gives you a fixed time to access this, right? On the other hand, linked lists, if you want to traverse to go to a certain element, if the element is at the beginning, it takes much less time than if the element is at the end. Because if the element is at the end, you have to traverse the list until the end. So it takes more time to access different elements, right? Different times to access different elements. That means the access time of an array is good. But what about linked lists? What is something that may be good for linked lists compared to arrays? Would you say this again? Exactly. It's easy to insert in between. or even delete, right? Remember I told you if you want to drop a course from our quizzes, you already, because back then you didn't know linked lists, so you implemented your list as an array. If you drop a quiz, and this, if you drop a course, and the course is in between, like it's an element 4, right? And you have 10 elements. What you should do, generally, you should take this course away, right? And then shift everything 5 to 4, 6 to 5, 7 to 6, right? You shift all the elements of the array in order not to have a hole in the middle of the array. So it takes more time to delete things. What about linked list? Linked list, because you can think of this as pointers, we will see right now, it's very easy to delete. You just take a node away, then you make the pointer of the previous one to the next one, right? So insertion and deletion from linked list is much faster than normal arrays. Good? So there are advantages and disadvantages. Which one is good? It's dependent on the use case. If you know that your use case you want to insert and delete a lot, you do in general read and writes a lot, then linked list may be good. But if you know that you just initialize it once and you keep only reading it, you don't modify it, then arrays may be good. Right? You see now we are comparing different implementations of the same concept, which is a list abstraction data type. Good? So just to wrap up what we said last time, an abstraction data type, or any type of, when you talk about programming, it has a set of values and a set of operations that can be applied to these values, right? And abstract means take away the implementation, right? You just define the contract between you and whoever is going to use your abstraction data type. Data structure is the implementation of this abstraction data type. We already discussed this. Yeah, this is kind of connecting this slide and the coming two slides. They are connecting what we discussed before, why we need even object-oriented programming mentality and the setters and getters with the concept of abstraction data type. Everything has the same mentality, which is we said we should separate the abstraction from the implementation, right? In other words, which we said before, we should separate the interface from the actual implementation. We said how we separate this interface from the implementation. The user shouldn't have access to the actual implementation or the actual members of a class. The way to do this is to make them private and then do setters and getters at the interface, right? You remember this figure we drew? You have an interface. So the user is able to access all the members only through the set and get methods. And internally, the way you implement them is completely up to you. And then we said the benefit of this is what? What is the benefit of this? What is the benefit of having setters and getters and private members? Or separating the interface from the implementation? Someone else? Why we have object-oriented programming? Any idea? Yeah. And why would like to do this? This is one thing, yes. And security is another thing, right? You want to make sure the user will not tamper or modify or being able to hack into your actual implementation, right? This is just an example of using setters and getters. You have your private member variables, and then you have get first, and then get last, and then set first and set last. Okay. About the naming, this is just review. Then, yeah, what is the point? So, multiple of you already asked me this question after we discussed setters and getters. If I'm able through set to modify the variable itself, then it's very equivalent to say, just have access to the variable and modify it, right? So set x, what it's doing is taking an input and then modify x. Then it doesn't seem that much different from allowing the user to directly modify x, right? The difference is actually the following. You remember our point class, right? We had x and y as our coordinates, right? then assume you provided this class to a user, and then you provided public access to X and Y. And then after some time, you find another more efficient way of implementing the coordinates. For example, instead of having this as X and Y, you use the polar things, which is like the angle and the distance from the origin, right? Like theta and r. Now, these two are completely different than these ones, right? You are moving from X and Y to theta and r, different implementation of the same point thing, right? If the user have public access to X and Y, are you able to do this? Are you able to shift into the polar coordinates? Will I be able to do this? What do you think? Okay, so think about it. Yeah? Think about it, and then you guys will get what does it mean. Good. So if you think about this, you will know what we mean by importance of a contract. Another thing that is important in object-oriented programming, and it's also related to abstraction data types, is you shouldn't promise more than what is required. What does it mean? So assume you are writing a class and then another programmer is going to use it, or a user is going to use it. Good? The user is telling you, I need these requirements. Usually happens. You have a set of requirements that you want to comply to in your class. These are 10 requirements, right? But then you find a way to enhance your class, and then you actually wrote it and enhanced it. A good programming skill, in fact, may seem counterintuitive, is you shouldn't tell the user or the programmer about your enhancements or additional requirements that makes it faster. Why? Because maybe later you either discover a bug in this enhancement or you discover a completely different way of doing things, right? You just should comply to the contract, no more, no less, right? This allows you a more flexibility and freedom later to modify your own implementation of the abstraction data type as far as you comply to the interface. And this is the main reason why we have abstract classes, we have interfaces, or in general, we have abstraction data types. Good? So if I want to assume, take the example of a list as we discussed before. A list is an abstraction data type that I want to implement right now. What does it mean to implement an abstraction data type? You want first to implement all the operations. First of all, have a way to organize the values in this abstraction data type as promised by the abstraction data type. What does it mean? For example, if I'm telling you I want an ordered list, then you have to maintain a certain order, right? If I told you I want another abstraction data type that is a set, that means you shouldn't have any duplicates in a set, right? Other things, we have queues, we have stacks, but forget about these now. Let's take the set example. You want to have your values in a certain way, a list of values, right? This is the way you should organize your values. You should have a data structure that organizes them in this way, right? It's one thing. The other thing is the abstraction data type gave a promise in the contract to implement certain operations in this list. For example, in the lab, you do insertion, you do deletion, a copy may be initialization, right? These are the things that the abstraction data type is promising. Then implementing an abstraction data type means you should implement an algorithm that covers all these methods, right? So you should write an algorithm for each necessary operations that are promised by the abstraction data type. Maybe when doing so, for example, in the lab, you do a copy of a list, right? But while you're doing a copy, you discover you need an auxiliary function or a method that does something, like take it node by node, for example, or traverse the list. Any auxiliary method you do behind the scene shouldn't be visible to the user. Again, it's not part of the contract, but you need it yourself to satisfy the contract, right? One example would be, I ask you a question at the exam to write a function, right? But then as part of this function, you find it's a good idea to write an auxiliary function or a method that you do a certain operation. It would be faster and easier to write the code. Feel free to do so. As far as you comply to the original question function, write how many functions as you'd like. It's actually a good idea to write as many methods as necessary because your code will be organizable and extensible and easily readable. All of these advantages of having a good structured code, right? So yeah, this is behind the concept again of abstraction data type. Your members are generally private, which is your responsibility to secure them by having them private or final or protected. Like we have different tunes or different knobs to tune your security of certain members. But then you also should provide an access to the contract or other users or other programmers to modify these through setters and getters. Okay. So let's stop here. This summary is just covering what we have said. Then next time we start from linked lists. Or for those who would like to see their midterm exam, so today you can come to my office between 2 and 4. Okay? Between 2 and 4, my office in ITB. You can come and see your bib.